Okay, it's time for us to look at integrals that are more challenging than the ones we saw yesterday. And again, you need to understand, and this is really the basis of Calculus 2. Calculus 2, much of it is finding challenging integrals. There are integrals that we cannot determine on our own. There's integrals that we can't solve. You can really take the derivative of just about any function that you see, but taking antiderivatives, super tough. For example, look at number 1. You see it right away, because of what we did yesterday, you'll be led down the path to say that u is equal to what? X squared plus 2. And right away you say, well, I know u should be x squared plus 2 because it's on the inside, like it's that parentheses thing. But there's also this inner feeling inside where you say, you know what? I know that when I take the derivative of it, I should come up with something else that's sitting there. And right now you realize that when you take the derivative of x squared plus 2, you get 2x dx. And so you know that there's a problem because the 2 doesn't bother you, does it? But the fact that you just have an x and not an x cubed, that makes you extremely uncomfortable. And it should, because it's a huge, huge problem. And so therefore, I'm going to choose to rewrite this integral in a slightly different way to help you see how we can solve it. I'm going to raise the integral of x squared times x times x squared plus 2 to the 5th power dx. You don't have to do that every time. I'm just doing it right now for effect. What do you think? Is that okay? You okay with making that step? I just wrote as x squared times x, which is x cubed. So I have the x, don't I? And in fact, I could take 1/2 du is equal to x dx. So right now, you're like, okay, x dx, gone, right? X squared plus 2, gone. But what do I still have? Got that stupid x squared. Yeah. See, do you see where we have an x squared? Isn't x squared just u minus 2, as Chris said? So all of a sudden, we were able to get rid of all of our x variables and use our u variables instead. So let's go ahead and write our integral. We now have the integral of 1/2 du, and I'm going to cross stuff off so that I stay organized. 1/2 du, what can I get rid of? Now they wrote 1/2 du. X and dx. Good. X squared, what do I put in place of the x squared? Yep, so I got that gone. I do this u minus 2. And then instead of x squared plus 2 to the 5th, I do u to the 5th. See how they're all gone? So now it's no big deal. I just distribute the u to the 5th. I have 1/2 integral of u to the 6th minus 2u to the 5th du. Well, what is the antiderivative of u to the 6th? U to the 7th over 7. Minus, what's the antiderivative of 2u to the 5th? 2u to the 6th over 6, or u to 6 over 3. Thank you for asking the question. So, I can't take the antiderivative of this just like it stands. Right now, the only way that we know to do antiderivatives is either by using substitution or creating polynomials. So I'm going to distribute the u to the 5th. So u to the 5th times u is u to the 6th. And then u to the 5th times 2 is 2u to the 5th. So when I distributed this to both of these pieces, I came up with the expression that sits here. Now I do the antiderivative. I have plus c. I place x squared plus 2 back in. I get x squared plus 2 to the 7th power over 14 minus x squared plus 2 to the 6th over 6 plus a constant. Now, you can hold to whatever thoughts you have. You can, you know, you can say math is stupid. You can say I hate calculus. Say I'm never going to use anything. You can hold to whatever thoughts you have. But everybody in this class, if you can't do this, there's something missing. You should be able to look at that and say, if I take the derivative of that and I come up with that, wow, that's pretty incredible because I don't see it. Anybody else with me saying that if you take the derivative of that, you're pretty impressed that it would end up coming out to be that? I mean, that would involve a lot of simplifying, wouldn't it? It would. But it turns out that it does. And the antiderivative wasn't too bad for us to do. The power of substitution within integration is incredible. Let's look at another example. 4x to the 5th times x cubed minus 4 to the 3rd power. This looks challenging because I've got this x to the 5th sitting out here. I know that the derivative of x to the 3rd is 3x squared. So that bothers me. But fortunately, we have a better choice here. I'm going to take this and say that u is equal to x to the 3rd minus 4. So du is 3x squared dx. Only for teaching purposes, I'm going to write this out as the integral of 4, and I'm going to write it as x cubed times x squared times x cubed minus 4 cubed dx. We're looking for that antiderivative. That must be challenging, but we can do it. Okay, I don't have a 3x squared. I have a 4x squared. So what are you going to do? Multiply by 4/3. We'll divide the 3 off. We'll multiply through by 4. So 4/3. 4/3 du is equal to 4x squared dx. At that point, I do like to set up my integral. I have the integral. I have 4/3. I have dx. And that allows me to get rid of the 4, the x squared, and the dx. Sure. Now, play with the constant however you want. Great. Now what? U plus 4. What in place of the x cubed minus 4? U to the 3rd. Awesome. Now we've got an integral that's easy to work with. What did I do? Oh, thank you. Yep, du. So I have 4/3 integral of u to the 4th plus 4u cubed du. Antiderivative of u to the 4th. So 4/3 times u to the 5th over 5 plus u to the 4th plus a constant. I will place the x cubed minus 4 in for u. So I have 4 times x cubed minus 4 to the 5th power over 15 plus 4 times x cubed minus 4 to the 4th power over 3 plus c. The derivative of c is 0. We attach a dx to say that it's a derivative. It came from something. It came from something else. Okay? So when we take this derivative, say we have 4x squared, and you take the derivative and you say 8x. Instead of 8x, we say it's 8x dx, just representing that it was a derivative. It came from something else. Okay? It came from something else. Okay? There's notation where we use f prime of x. Do you remember we use notation of dy over dx is equal to f prime of x? So when you multiply both sides by dx, you get dy, or the derivative, is equal to f prime of x, which is your 8x, and then we attach a dx. That's another way to think of it. A lot of it's notation, and the notation just gets to be used for different circumstances. Okay? You ever had that moment in math where your brain's like, "Oh, I see that." Does that happen? Hopefully it happens a couple times a day. We're like, "Oh yeah, oh that connection." Like, my guess is that when people saw that substitution piece, you're like, "Oh, I didn't see that right away." I'm glad Chris pointed that out, right? Okay, let's try the more challenging one, and we're gonna allow your brain to grow again. The integral of cosecant to the 4th times cotangent dx. Okay, Chris is making an assumption that u should be cosecant. Maybe u should be cotangent. Here's a point where you maybe need to make a note. If you have the cotangent of x, what's the derivative? Negative cosecant squared of x dx. Do you have a cosecant squared up here? Yeah, you do, but you actually have a cosecant to the 4th, don't you? And then here's another one. If you say, well, we're going to use cosecant, what's the derivative of cosecant? Negative cosecant cotangent. Do you have a cosecant cotangent up here? Yeah, you do. So the question is, which one is going to work best? And the answer probably lies in just rewriting the problem. The integral of cosecant cubed of x times cosecant of x cotangent of x dx. Do you see that one little trick? I just rewrote it so that instead of cosecant to the 4th, it was cosecant to the 3rd times cosecant. So it looks like that is what I want to come up with. Agreed? So therefore, I'm not going to choose u to be cotangent. I'm going to choose u to be cosecant. U is equal to cosecant of x. So du is equal to hey, I don't have a negative, but that's not a problem for us, is it? All we do is we just multiply by a negative. Negative du is equal to cosecant of x, cotangent of x, dx. This is my favorite part when I get to write the new integral and start crossing some things out. I have the negative, I have the integral, I have the du. What do I cross off? That guy. Yeah. Way to answer your own question. Good job. You're a smart man. What do I replace cosecant cubed with? U to the 3rd. Well, that's such a simple integral, isn't it? we took what looked like a super complicated problem, and it's no big deal. What's the antiderivative of u to the third? Done. That's cool. Close. But I think we should look at one more. Why does this one anger you a little bit? Yeah, like the fourth root thing. Isn't that amazing that it doesn't matter what class we're in or how old we are. If we see that, number one, it brings to your to your thought, it brings radicals, doesn't it? I mean, and it also brings this idea of fractions. And it doesn't matter where we are, division and fractions, like we do not like it, right? Yeah, that's right, and that's not how we're wired. That's not how we're wired at all. We're wired to do addition, and addition just leads into multiplication. But division and fractions, that's not how we're naturally wired. And that's what makes it challenging. Fortunately, we're going to make this easy for you, okay? But keep an eye on this, okay? This is the derivative result when we find the antiderivative. And so it's going to be incredible to see how this thing changes. Somebody want to suggest what u is? It is just 3 minus x. This one's going to require a little careful attention on our part. So what is du? Is that just, it's like, look at that, it's the negative dx. What do I do with the negative dx? Times it by negative 3, multiplied by negative 3. Negative 3 du is equal to dx. Okay. Whoop, 3 dx. So it looks like I've taken care of the 3 and the dx. And then the bottom, I would have u to the 1/4 power, right? So don't worry about the bottom. Bottom's just u to the 1/4. That's stinking x squared. I don't have an x squared anywhere on the board. Make one. Times it by x squared. Do it. U x squared equals 3x squared minus x cubed, like that. Divide by u. I love it. Yeah, let's roll. We can't attach u and x together. We have to have u by itself eventually. Yes, if we're changing, we're going to du. So everything has to have a u. We can't have x's. Chris? Thought? No? X equals 3 minus u, right? Ooh, x squared is equal to 9 minus 6u plus u squared. Look at that. He just like, that's like 40 million neurons, just all of a sudden going together. Like, you just got smarter right there. Oh, yeah. There it is. I solved for x. X is equal to, I squared it, so I get 9 minus 6u plus u squared. Isn't that awesome? So let's do, right, exactly. Let's cross some stuff off. I've got negative 3 integral du. And if I write negative 3 integral du, what do I get rid of? The 3 and the dx. What do I replace x squared with? 9 minus 6u plus u squared over u to the 1/4. Well, I can't do that. I got to write it as a polynomial, right? Yeah, split the fraction up. -3 integral. Instead of 9 over u to the 1/4, it's going to be 9u to the -1/4, right? Minus 6u to the 3/4 plus u to the 7/4. Yeah. Oh, yeah. It's got to go all the way through to each term. It's like you're factoring it out. Okay. Now I do the antiderivative. -3 times, that'll be 9u to the 3/4 divided by 3/4, right? You know what? We might be able to work it through. I'm going to save that for the next step because I'm afraid I'm going to make a mistake. And when I make mistakes, you guys make fun of me. And I feel worse about myself for the rest of the day. So, minus 6u to the 7/4 over 7/4 plus u to the 11/4 over 11/4 plus a constant. What are you talking about? The rule for the antiderivative is the antiderivative of x to the nth is x to the n plus 1 divided by n plus 1. That's the rule, right? The antiderivative of x cubed is x to the 4th over 4 because when you take the derivative, the 4 is going to cancel out, right? Right? Yeah. You got it. You're there. Okay. I'm going to have to take care of these constants now. So I multiply by 4/3, right? So then the 3's will cancel. So I should get 36. But then I have this 3, right? Okay. Watch. If I multiply by 4/3, these 3's will cancel then, right? So 4 times 9 is 36. Negative. So -36. What is u? 3 minus x to the 3/4. Okay, I'm going to do this again. Multiply by the reciprocal, and I get 24 times -3, 72. It's going to be positive, so plus 72. And it's going to be over what? 7? 3 minus x to the 7/4. So plus 72 times 3 minus x is 7/4 over 7. Good, I've got that one. The next one going to be plus or minus. It's going to be minus. So divide by 11/4, I can multiply by 4/11. So I'll get that 12/11. 3 minus x to the 11/4 plus a constant. Chris read my mind. So that's what's absolutely incredible, folks, is this guy right here. If you were to take that derivative, you actually would come up with this thing sitting right there. And if you're able to see that, you're much better mathematician than I am, because I can't. You take the derivative of that, somehow you come up with that. I mean, folks, yesterday we started like this. We said that if you have sine of 3x, we said the antiderivative was -1/3 cosine of 3x plus c. And you can make sense of that, right? You can see, oh yeah, I can see how you go from one to the other. Well, it turns out that the antiderivative of this is this. And if you saw that ahead of time, wow, you were good. There's people, but not me. You guys go to work, finish off that worksheet. You got one lesson left on this before we're ready to kind of get moving. So I'll have the study guide ready for you tomorrow.